In this tutorial, we are going to learn how to use the Winson WCS Hall effect current sensors to measure the current and display it on LCD1602 or LCD2004 with I2C module, which has only 4 wires. You can get the code for this by clicking on the link below the video in the description, which will take you to robojax.com/learn/Arduino. Let's get started with this. I have a separate introduction video to Winson WCS Current sensors, and I've written the library for this so you can use it with LCD very easily or without LCD with full explanation and detail. This video I'm not going to explain it, so please watch that video, otherwise you will have a lot of questions. So the link for that video is below this video. Make sure that you are able to measure the current and display it on the screen. In this tutorial we are going to just use one of them, which the code will work for all. I'm just using one WCS 1800 with a LCD1602 or the LCD2004 with 4 line, and we will be able to measure the current. Because when the load is not connected, we have a 0 current value, meaning the sensor always reads some value. We have to subtract it from the actual reading. So we do that at the beginning of loading this. We can set the time in Arduino, which is currently set to 5 seconds. Within first 5 seconds, it will read the 0 current, and here I put it as ZC, so it is 3.22 ampere. It shows continuously in here. And when you're using 2004, then you will be able to see one line and then the current and then 0 current. Of course, you can hide this 0 current if you don't want it from the code, so you can turn it on and off in both displays, either the small one or the large one. Make sure that when you turn this on, when you reset the Arduino, make sure that there is no load connected, so this can read a proper 0 current. For example, right now it says 3.14. Reboot it. I just press the reset. You will see that it shows a current and then current sensor, and after that it reads the 0 current and it shows the 0 current 3.18 ampere. We are going to just use one of them, which the code will work for all. I'm just using one WCS 1800. And now let's see, this is your load, and you have a battery and you have a sensor. Doesn't matter which sensor you have. You can have this type of sensor without a PCB with a hole through, or you have the sensor, this shape of sensor that will pass hole through, or maybe a module, something like this, that a 2 wire will be connected here, which I'm going to show you, or this module, or this type with the 2 terminal on the side, or if you have something like this, or something like this. You can put it between the negative and the load, or you can put it between the positive and the load, or you can put this one between positive and the load, and it will just pass through that. Or you can put it at the negative, the same module here. Or if you have this type of module, you can solder the 2 wires between the negative and the load, or between the positive and the load. And if you have this PCB version, you can connect the 2 wires in this 2 terminal, or between the negative and the load. And if you have this shape, you can also connect it between these 2 terminals, something like this, or between the positive and the load. When connecting the wires, all WCS sensors, they have 3 wires, and the 3 wires are labeled as VDD, ground, and Vout, all of them. So VDD will be connected to 5 volts of Arduino, ground will be connected to ground of Arduino, and the pin that is labeled Vout will be connected to analog 0. And each module has datasheet, and on the datasheet they're all aligned in the same way. So we have VDD, ground, and Vout. So you can get that from the datasheet for each module that you have. For example, this is for WCS 1800. If you have this type, VDD, ground, and analog out, or for this one as well, the same way, VDD, ground, and analog out, the pins are connected in the same way. This is the negative of my power supply, and that's the positive. The negative I've connected directly. This is the load. I'm connecting it to my load, and this is the positive, passing it through this, and will be connected to my load. This is my load. Here I've prepared this wire. This is the 10 AWG wire that can handle over 70 ampere. So I'm going to connect it like that. Pay attention when you're wiring the bare module without the PCB. You have to connect between the V out and the ground. We need to connect a capacitor, 0.01 microfarad, that is 10 nanofarad, to 0.1 microfarad, which is 100 nanofarad, to reduce the noise. But if you're getting PCB, the capacitor is already included. This is a capacitor. And on this module, this is a capacitor. It's already included. This side is VCC, green. Green is connected to pin 8, where we define this pin 8 as additional 5 volts. So this pin now works as 5 volts. And then ground, this purple is connected to ground here of Arduino. And the last one is analog out, the gray. Gray is connected to analog 0 here. And here for the LCD, either this module with 2004 or this 1602, they're all the same. For this, from this side, the first one is ground. Ground is connected to ground of Arduino in here. And the second pin is VCC, which is connected to 5 volts of Arduino. You have to connect it to this 5 volts. And then this pin from the last second is SDA. The orange is connected to analog 4. And last one is SCL. It is connected to analog 5. So these two pins are I2C pins, or you can connect it directly to these SDA and SCL in here. If you need the wiring diagram for this, it is available as part of my Arduino course at udemy.com. If you want to learn Arduino, I have a bestseller course on Udemy where you can learn Arduino from ground up with hundreds of projects. Now let me explain the code. First, you need to download the library. I will provide you the zip file. Once you click and download it, save it in your computer somewhere. After that, click on Sketch, include library, add .zip library, and then point it to where you have saved it. For example, in my case, if it was inside download and tutorial, and if this was a zip, select it and click open. After that, make sure to close Arduino. If you have multiple of these at the bottom, close them all and reopen it so you can see the list of library and all the options. Then click on File, Examples, and scroll down until you see it with R, Robojax WCS Current sensor, and here you will see Robojax WCS LCD. And here is the code. You have to select your module, whatever model you have. If this is the model that you're using, you will select 0. So read this from this list and find out which number belongs to the model that you're using. And for this test, I'm using WCS1800 and the model is 12. So find out the model that you have. It must be there. And here we are creating including the Robojax WCS library. Here we are defining the model that we have, 12. And here we are defining the analog pin for the sensor where we read it. And this is the sensor VCC pin, pin 8. This setting from this line below is up to here. That's for the LCD. And this is the I2C address, or I2C address for the module. This module's address, it has its own address. Either if you have larger one, for both of these you need to know the I2C address. As you can see, I've already printed them. In order to get that, go to File, Examples, again WCS Current library, and then I2C scanner. Open this. We do not worry what is inside it, just upload it. If the wiring and power is up, upload it. And then open the serial monitor. It will show you the address 0x3f. This 3f is the address, 0x means hexadecimal. If you are not able to read it, on the right side, on the lower section, it says the baud rate and it says 9600, you must set it to 9600, otherwise you will not be able to read. So I'm closing this and closing this, and that is the address that we got from the I2C scanner. LCD character, how many characters it has. If you're using this one, it has 16 characters and 2 lines, and if you're using the larger one, it will be 20 characters and 4 lines. So we enter here 16 or 20 and enter here 2 or 4 depending on the module that you have. Title current, the word current, and then this title 0 current. These are the 2 titles that are displayed on the screen. Either on this small screen as well you will see the current, but if you're using the larger one you will see also 0 current. So you can change this accordingly to the other language that you prefer. This line has been commented out. If you're using another pin for VCC to supply 5 volts for the LCD and leave the 5 volts pin and leave the VCC empty for other purpose, uncomment this like that. So you will define a digital pin here. In this case pin 9 will be defined for the LCD. I don't need it, so I'm going to use the VCC. And here 0 current wait time, how long it should wait to measure the 0 current, 5 seconds or 5000 milliseconds. Correction value, this is through experiment I found out that 164 will correct the reading, and if you wish you can change it, either reduce it or either put minus value or plus or 0. Measurement iteration, how many measurement you do, 100 or 300 or whatever. You can, the larger the value, the more accurate the reading, but it will be slow. You can find out what number works for you. And voltage reference, this is 5 volts. This module can work, for example, up to 12 volts, but if you are powering it from Arduino, you can put here 5000. I recommend to use 5 volts because Arduino will work with this. And then the bit resolution is the resolution of analog read, and if you are using Arduino DUI or MKR, it will be 12 bits. So change this 12 bits, and if you debug one, you're running the debugging to display information, which I'm going to show you next. You can set this true, so it will be shown only once. I'm going to demonstrate that. And here we are creating an object from the class, call it sensor, and we pass all the values that we define above in here with comma. All the values that we defined, it will be passed to the class for the library to be used. And if you're defining a digital pin for 5 volts, make sure to uncomment this. You see these are already commented. To uncomment it, just select, right click, and then it says comment, uncomment, and now this will be uncommented. But you cannot use both of these, so we have to comment this out like that. Now this will not be used, and the one that has this VCC pin will be used. I'm not using it, so I'm commenting this and uncommenting this one. And inside the setup, we define the serial monitor with 9600, which I have just shown you. You must set that the serial monitor when you click here the same value. This is just displaying the text on the serial monitor. Sensor.begin, initializing the sensor. So all the pins and settings will be set and it will be ready. This line is printing the sensor and printing the sensor model. If every time you need to get the model of the sensor, just type sensor.get model with this function, so this will return the value. In this case we are just printing it, making sure that the model that you've selected is the model that is that you have. And this is library version. It will print the library version, sensor.version, so this way you know which model you have. And if you want to see all the available models, just uncomment this and let me upload the code. And let me open the serial monitor, and after 5 seconds 0 current reading, let me remove the auto scroll. Here it prints the model that you have selected. If you have selected 12, it will be like this, and other number will show proper value, so you can check with your model. And here this is the library version. It says version 1, and then this is the text from the these models. When you print the model, it also, when you print all the models, it also prints again the version, and each model will be displayed. So you know this is the model and this is the number that we need to use, and this is the sensitivity of the model. I uncomment this and upload the code, and open it again after 5 seconds of zero current reading. Now it shows the version and the model only. We must have this line, otherwise you will not read the current. It says sensor read current, so this will read the current and display it on the screen, and we have 1 second delay. You can reduce or increase it as you wish. And this is sensor print debug. This will print the debugging information. All your settings and everything will be printed on the serial monitor. Let me uncomment this and then upload the code, and let me now open it. So, and here as you can see, it, after printing up to here, it printed the model, and so it says reading from pin 14. Do not worry, analog 0 is pin 14 on Arduino Uno. After pin 13, analog 0 is pin 14, and VCC pin is pin 8 for the sensor, and this is the sensitivity and the zero current voltage that have been recorded, the voltage reference, the correction value, the bits, and the zero current time. And after that it will show the current that has been measured at that last moment. So you can uncomment it and get rid of it like that. And if you want to display the current on the serial monitor, this is, you use sensor.print current. Now let me uncheck this and upload the code, uncomment. I've uncommented this line and upload the code. And this is how it just prints the current on the serial monitor as well. Now let me demonstrate it. When you turn it on, initially it shows the zero current. The zero current have been recorded as 2.75 ampere. So this should happen before you connect the load. Make sure the load is off and then turn this on and wait until you see this. Now I'm going to do the reset switch in here, and let's see. It boots up current sensor, and once it is recorded, then it shows the zero current. Now this is the current at the moment, because we see here that value. Let's go 10 ampere. And now this is 10 ampere and we are reading 9.6 here. Almost 400 milliampere deviation. Let me go 11. So 500 milliampere or 12. This is the actual current, and now let's go 15. So that is now 14.75, 250 milliampere. It got accurate. Now let me increase it slowly. So we are now at 16 ampere, almost 200 milliampere deviation, 190 something. 17, so it got more closer. 18, so 19 ampere, almost 150 milliampere deviation. It got very accurate now. 20, now at 20 ampere we are reading almost 500 milliampere deviation. Let's jump to 25. Now this is 25 ampere is passing through this wire, and we are reading 24.9, very accurate, 100 milliampere deviation. So let's go 30. Now the current is 30 and we are reading 28.4. So now this is now almost 1.5 ampere deviation, which is not good. Let's go to 35. We are reading 31, so 4 ampere deviation, which is very bad. So what we come to conclusion is that if I go for 25, we are reading the most accurate value at 25. So 9.6, almost 400 milliampere deviation. Let's go 2 ampere, very low value. Now this is very accurate with comparing to the previous value. It's almost less than 100 milliampere. Let's go 1 amp. So 920, and this is 1002. Let's go 0.5. Now this is 500 and we are reading 440. So still, because this is made for higher value, still it's acceptable. So keep that in mind, that we can measure up to 25 ampere. Connecting the large display, so I'm changing the I2C value, changing this to 20 and this to 4, uploading the code. As you can see, it shows this text first, and it shows the zero current to be 3.68, and here is the mistake that I made, and it was on, so I have to turn this off and then press the reset switch so we can read it properly. Now that there is no load, load is off, and now we are reading proper value and the zero current is displayed. Because this is larger screen, we can put the proper text here. And if I go 25, it shows the same as before properly. And here is a problem. In case even at 25, if you press reset button or the load is connected, when you turn this on, here is what you read. It will record 25 as zero current. It thinks that there is no load supposed to be. So 28 is now. Remember, it was 25, 3 point something. So now plus 25, it's 28. Now this is reading it. Now if I turn this off, you will see minus 24.9. So that 25 was there. So in order to avoid this, make sure that the load is off like that, and then press the reset button, this reset button, or turn this on the power, or turn the power on. Now it will record the zero current, then you can proceed. So if I turn it on now, 25, and we are reading very accurate value. Thank you for watching. This was how to use the Winson WCS Current sensors with the Robojax Arduino. If you learned something and found this useful, please thumb up, as this will help my video in the search algorithm of YouTube. If you have comment or question, please post it in the comment section below. I try to answer and reply. And to get updates of my upcoming videos, make sure to subscribe. In this tutorial, we're going to learn how we can use this Allegro current sensor ACS770. They are available in a range of from 50 to 200 ampere. I'm going to test it with 50 ampere. This is a serial monitor, and this is my load, electronic load, that is taking 50 ampere.